Tracking constraints are a type of constraint that allows for one object to point to another object in some way. Instead of copying the values of another object, tracking constraints take into account the relative location of the reference object, or target object, in relation to the selected object. Let's go ahead and look at how each of these tracking constraints work. Keep in mind that all of the constraints and concepts we show in this video are the same for bone constraints as well. So let's start with the most basic tracking constraint, the track to constraint. First things first, because the track to constraint does affect rotation of the object, let's use a monkey instead of a cube to make it more obvious. You can do this by deleting the cube and going to the Add menu, going to Mesh, and selecting Monkey. From here, we can select our monkey and go to the Constraints tab in the Properties editor to add our constraint. Under the drop-down, you can choose Track To. We can already see that we need to input a target object. This will be our light, because it's already in the scene. We can either select it from the drop-down menu, or use the eyedropper tool to left-click it in our 3D viewport. Immediately, the monkey starts to face the light, except that it's not actually facing the light, it's facing directly away from the light. But still, if we move our monkey or our light, it's clear its transformation is taking the light's location into consideration. So how do we get our monkey to stare at the light object? Well, let's go into the Track To constraint options, and you'll see a few axes we can choose from. What does this mean? Well, these axes correlate to our monkey's local axes, but it's not very easy to visualize. So let's go into our object settings under this orange cube icon in the Properties editor and go down to Viewport Display. Expanding this will reveal a couple of checkboxes including axis. Check this on and you'll see that we can now see the axes of our object visually in our viewport. Now, if we go back to our Constraints tab, these axes letters might make a bit more sense. For example, up being the z-axis and y being the 2-axis. So it's clear that the y-axis is pointing at the light object, and the z-axis is considered up for the object. Now, to face the monkey towards the light, it should be obvious now that all we need to do is select the negative y option instead. And that's it! Our monkey now faces the light no matter where the monkey or the light are in the scene. Feel free to play around with the other settings to better understand the constraint. But for the most use cases, this is all you'll need. Let's take a look now at the other related tracking constraints, that being the locked track constraint, the stretch to constraint, and the damped track constraint. Each of these is exactly like the track to constraint, but with some important differences. The locked track points an object towards a target object, but only along one axis. For example, by adding this to our monkey, you can see that it now can face the light, but will not look up or down or tilt its head. The lock axis at the bottom of the locked track constraint refers to the only axis of the constrained object that should be rotating. The stretch to constraint works very similarly to the track to constraint, with the only main difference being that the object will actually stretch or contract based on the distance between the two objects. The object will stretch if it gets pulled past the location it was at when the constraint was applied, and contract if it gets pushed closer to the object that is pointing to. You can, however, reset the scale of the object at any time with the Reset button in the Stretch to Constraint settings. And volume settings help control how much the shape of the object should change as it stretches and contracts. The rest of these settings are typically fine if you leave them at default. However, feel free to experiment further with these settings to better understand the constraint. The damped track constraint is very similar to the track to constraint, but removes the parameter for the up axis. Instead, it simply calculates the least amount of rotation needed to continue pointing at the target object. This allows it to feel more smooth compared to the track to constraint, but also gives you less control in the orientation of the monkey's head. Finally, we have the clamp to constraint. This is not exactly related to the track to constraint, but allow me to show you what I mean. Let's just go ahead and add it to our monkey head real quick. Seems simple enough. let's add a target object like we have for all the others. Except that we can't. In fact, if we go to the drop-down menu, you'll notice that our options are empty. That's because the Clamp To constraint deals specifically with curve objects. But what are curves? Well, curves are smooth, math-driven shapes that can be used as references for a variety of things. To see what they can do with the Clamp To constraint, we can add a curve from the Add menu under Curve. Then select Bezier Curve. Just to make things more clear, I'm going to scale this curve up a bit so it's large enough to see. From there, we can set this new Bezier curve as the target object of our Clamp To constraint on our monkey. As you can see, the monkey immediately snaps to the curve's location. But if we try to move the monkey, you'll see exactly what the Clamp To constraint really does. It clamps or limits the monkey's location to follow the curve. This can be very helpful when trying to keep an object on a certain path during animation. Checking cyclic will even allow the monkey to wrap around after reaching the end of the curve, and feel free to experiment with the axis options to better understand the constraint. These are the fundamentals of the tracking constraints in Blender.